Hey guys, good morning. Thanks for joining this month's session. So we have piled up quite a few topics to discuss. So let me come back to this one. This topics, whatever we are going to discuss. Let me show. This is my meetup URL, and sorry, this is my GitHub URL. And I'll give you the code where we'll have this session's details. Okay, I'll give you both right now. So one is this. I just am the guy who will be dealing with both. So I'll switch between. I might be little delayed in answering the queries, but we'll definitely take any queries whichever are coming at the end. Okay, so those are the URLs, and this event today, whatever we are going to discuss. So we will be discussing on these three items. So let me walk you through that in the documentation. So the documentation is this one. So I'm learner, so apologize if I do any mistake. So first we'll look at the 30,000 foot view of Docker, just enough Docker for us to get going into the ECS or FarGate. So before that, we need to have enough knowledge of what is Docker, or a little bit on images and containers and image registries. So we need to know those fundamentals before we jump into the ECS and play around. So the strategy is that today we'll work with an existing images without knowing how to create our own image. We'll focus only on there are existing images. How do we access that locally? How do we use it in ECS or FarGate? So that is the plan. So in the next week, what will happen in the next episode, what we will do is we will create our own images and reuse it in the same manner. So that's the next step, advanced step. Now someone has created an image, we are using it. So in the next session, what we will do is we will create our own images, push it to the Docker Hub, and use it in the ECS or FarGate. That's a plan. So please fasten your seatbelt. And as I was mentioning, I'm still a learner. Apologize if I do any mistakes. So let's start. So I will sometimes switch the side to see if at all there are any queries, but as I'm the only guy, so I might take the queries at the last. So let me go and spend rest of the time on the session, and I'll stop at last. So please keep a watch on this meetup group for all the future sessions, and also please fill a form that I'll speak about the form little later. Okay, so let's come and discuss about this one. So Docker is a platform which enables us to quickly deliver the project or the deliverable to the production very quickly. So it helps us in shipping, testing, deploying quickly. Okay, so that's Docker as a platform as well as it's a company also. So the key thing to discuss here is the Docker architecture. So if you see that Docker is made up of two things, like a client and a server. So the server, or technically it is called as a Docker host. So the Docker host is a server, and that helps us to spin this containers from the Docker images. So you can have the Docker images locally, or you can have Docker images in some registry. So the registry could be the public registry, or the registry could be the private registry. So we'll come back to the registry. I'll just would like to walk you through quickly. Okay. So first, let's speak about this Docker daemon. He is a server, which is a key guy who does all the heavy lifting. Okay. So Docker client is the one which communicates to the Docker host and make the things work, right? So here the Docker, we spoke about three key pieces. One is the Docker host, that's Docker daemon, or Docker server, just to be in a simple terms, and Docker client. So in 2014, when I was working in Docker, I we used to create two Linux virtual machines to set up the Docker. It was that of efforts in 2014. I just wanted to show you one of the image. Just give me a minute. So it was that tough. So there used to be one Linux VM where we set up the Docker daemon, and there will be another VM. There will be the Docker client, and hooking up these two and creating the images. Oh, it was pretty much efforts. If you see that, whatever I was talking about is this one, the simple demo, which is 8 years ago. It's in my repository. So I know how tough it was 8 years ago to work to set up a Docker. So that means the Docker daemon and Docker client, two virtual machines, two different setups. Any instruction is gone. Again, you need to go through that. So now the life has been very easy. Okay, come back. Let's come back to this one. We understood there is some server, there is some client, and there is some image. We'll see about this. We'll do a little bit of deep dive into that, and we'll see containers. So the next thing is what we are seeing is the registry. So if you see that hub.docker.com, that itself is a registry. So you can have your own private registries also, and you can have the public registry. So mine is, I use Docker for the community service. So I am good with the free account. Whatever they give, they will give one private registry, and rest all is public images. So I'm good with this public because it's all my community service projects. So nothing related to my personal projects. So I'm fine with this one, and it gives a lot of tools. I'm very happy with this one. And the second thing is you can have Azure. In Azure also you can have registry. In AWS you can have registry, private registries like, okay. So in Azure we call it as ACR, Azure. So this itself is container registry. You can see that itself is a Azure container registry. Similarly, we have AWS ECR. So if you see that Amazon Elastic Container Registry. So these, you can have the public registries, private registries. You can create your own private data center kind of thing and create the registries. So that depends upon what kind of image you are supporting. Something which is very particular to your company, then you will have your own private registry. Something you are giving as a open source, then you will put it in a public registry. Okay, so now we spoke about registry, we spoke about server, we spoke about client. Okay, so here we spoke that Docker daemon, Docker listens for that, exposes the API and manages the Docker objects. That means this images, containers, network, a lot of things will take as we introduce Docker in this episode or in this session, and again we'll come back and we will improvise on top of this. Just give me a minute. I'll have a glass of water. So another thing is you can have this Docker desktop set up. So the Docker desktop is the combination. It includes Docker daemon and Docker client. That's Docker. So you can have this Docker compose and the Kubernetes and everything. So here is the Docker desktop. This is my Docker desktop, and let's see this. This is my personal account, and it is a free plan because I use only for my community service. And you will have the Kubernetes as well as the Kubernetes and Docker both included. Okay, you can come and see the settings over here, and this is the Docker engine, and this is a simple Kubernetes version 1.25. Any software updates I'll see here, and it gives a pretty nice extensions. I'll show you on that extensions in a minute. So there are a lot of extensions. I particularly use this JFrog. So this shows, let's take this Mongo latest or whatever the image. I mean, we can scan our local image or the remote image. We can scan through this JFrog X-ray scan. So it helps us to find out the vulnerabilities. Maybe it is within us or the layers which we use it. Okay, so let's go. I mean, it will be scanning. Don't worry about that. We'll go little deep into that, and let's see one of the images. This one. So when I go and click on this image, so this is software bills of material. So it shows that. I mean, it might not be my layer, but it might be another layer where there might be some of the critical issues, some of the high issues, or those kind of things. So that itself is an entire a separate world or a big ocean. Okay, now if you see that we added this. I mean, a lot of people they create a Debian is one layer. So with that we started, and on top of that a different layer. So we are changing to command batch. We are installing this. Then we are setting up the ASP.NET URLs, and then we are setting up the version to 6.2. And then doing something. A lot of things are there. Then it's coming to app, and then exposing the port 80 and 443. Now the working directory is app, and we're publishing the app publish to this app, and we are starting .NET and Booksware DLL. All these things. These are software bills of material. Okay, it shows that. What is this? The key thing is here and here. Okay. So that's how this Docker desktop will help. Okay, someone who's pretty much a command line, they can do this, all these things through command line also. Okay, so this image is, what do we understand? Image is a layered thing. That means it's just like a template. Okay, template or a blueprint. And live instance of this image is container. So if I come into this one, the bookstore, that is this one. So if I go and click on that and check the terminal, in this inspect, you see that if I have to hit its port 80, I need to go on 8002. We'll redo this everything. If I have to go on 443, I need to go 8003. Okay, we can come and look at the logs. Let me delete the logs so we know that whatever we are hitting, it's going there. So this is, see that I went into this. Oh, I didn't start it. I'm sorry for that. Okay, it's running. So let's go now. and it started. I have removed that, and now it's able to access it. Come in here, and again I go to this books menu. So you see that now if I come back to home, and again if I go to books menu, so it's going to different layer. It goes to books controller and all those things, and it's bringing in this content. So that's how we execute. So I think we have learned just enough Docker, a 30,000 foot of what Docker is. We saw the Docker architecture here. We saw that the Docker's architecture. So we saw Docker host and Docker client. Oh, I would like to show that. Just give me a minute. Would like to show a couple of other commands. Docker. If I type this simple command, so it shows that what are the things which we can do. See this. Docker, a self-sufficient runtime for this one. And you have options and you have commands. So these are the options like debug and host, the log and other things. You want the version, Docker-v. So that's 20.10. And we have the management commands as well as the commands. Okay. And I was mentioning about the software bills of material, SBOM. So that gives you how that image has been tagged. Okay, we have other things has been features has been added like scan and other things, and you can see that attached build. We'll come back and do at least a little bit deeper into this. At least for today, we will see a couple of comments, pull and info. Okay, so rest of the things we'll see little later, but we'll see those two things. One thing is Docker info and Docker pull. That's those two commands will focus today. Okay, I'm saying Docker info. It gives the information. You can come and see this at the top. So this is client and this is server. So now you can correlate with this image. So it says that Docker client, the Docker client is its versions and everything, it's being displayed over here. And Docker host or Docker daemon, but we're calling it as Docker server. So you see that Docker server maintains the Docker objects. That's what we have seen. So there are 40 containers, 34 running, 6 stopped, and there are 31 images. This is the server version and a lot of other information. We can dig deeper into this one, but at least I just wanted to execute this command to show you that you can have Docker daemon and Docker client in two different machines, and the client communicates with the Docker daemon or server. And if you use a Docker desktop, it will be packaged with both the Docker host as well as the Docker client. That's the thing I just want to show. So I'll close all these things. Oh, I should have kept it. I'm sorry. Oh. So that's the Docker daemon, and this one we discussed, and we have seen that. Terminal. Let me open this terminal. To see Docker PS. This command gives you all the running containers. And if I do docker ps -a all, so one thing you can understand through this status column. So it says the status column is up, these are exited. So some of the other um, containers are there that is not executed. So now let's come and correlate like what is a image. We saw that books, this is an image. Okay, when we go into the image is made up of bunch of layers. We'll come back and analyze this. But if you see that this is a base image from Debian, we were able to able to create our own image. Okay, one more point to discuss here is if we go back to hub.docker.com here, and if I go and search and I liked any of those images, so you can go to the registries or want to go and explore something on that hub.docker.com, the repositories. I want to explore the repositories here to see what kind of repositories are there. So sponsored open source projects are there, verified publishers are there, official publishers are there. So you have to be very cautious when you're using any of the images. That means if they have any vulnerabilities, that means you are bringing those vulnerabilities with you. But most probably all the official, verified, and the trusted content, if you take it, you will be safe. But all the time you need to be cautious to do this scanning to find out are there any vulnerabilities which can be exposed and taken advantage of. So we have to be a little bit careful on that. And next thing is image is an executable thing. Sorry, container. Container is a runtime version of the image. So if you see that images is a read-only template, container is runnable instance of image. So if you see that the image for the bookstore is a template, it's made up of layers. And if you come to the container is executing. So it is using the image and it is executing. So now let's come back and we saw that how it executes. Let's go to the terminal. Okay, we'll come back, but don't worry if you don't understand anything on this one, but just observe this. You see that the bookstore core DLL and all this bookstore web and its DLL and a lot of other things are coming in here. See how many libraries. So this is where like PWD, print the working directory, this is app. I told this when we went into the images. And when we went into the layer, one of the things which we saw there is working directory app. Now that we can see that the working directory app has got all the libraries. So that's how the image is made up of layered thing, all the read-only layers. That's very, very important. There will be a thin writable layer. Once you kill that container, that layer will be gone. So let's play with this now. Let me come back over here. I will kill this. First, I need to stop that. And I need to kill this. So I killed it. That's gone. And another thing is I'm killing this nginx. I killed this both. And I'm coming back here. And I want to delete this image forever. Okay, that's gone. And let me bring nginx. Okay, this nginx is there. That's also right now it's not being used. I can delete it. Now, if I go and try to see any container which is nginx, I don't have that nginx or the bookstore. Let's spend quick. So we saw all these things to a decent extent. And now let's see that how do you bring in this, the nginx to your local, and how do you play? Right. So if I go to this one, the nginx, let's give it a minute to appear. It comes, this is an official image, 1+ billion of download and 10,000 Ks. They have given star to this content. And all you need to do is Docker pull. So let's take this and we will come back here. I will do the same command, execute and see that. Now see the number, we are not seeing the bookstore, right? And also we are not seeing the hello nginx. So we are seeing that some of the other things, but we are not seeing that. So now I will paste this and you see that it's pulling in this Docker image. Now you see that it pulls layer by layer. If at all any layer exists, it doesn't pull it. And if that layer doesn't exist, it will pull this. It's taking a little time. Let it take. Okay. I need to latest. Let's get the latest nginx. Okay, it's pulling that. Now you see that each of that ID here that represents a particular layer. So see that it's pulling all these things. Now it gives this. And now if I go and try to pull this nginx layer again, if I'm trying to pull that, it will not, because it will find all these layers locally. So see this, it did this, the latest, it's trying to pull the first, and it found that all these layers already exist. So it says that the image is up to date. If they release one more patch or a new feature in nginx, when we run, so it sees this, all these layers which exist, it will use from the cache, the already downloaded layer, and a new layer which has been added, it will download that. While we are here, why don't we pull the other sample which we are going to work is my shop web. Let me do that, because anyways, it's going to take a little bit of time. So this is my sample bookstore application, which I wrote it a year ago. So XBC payload bookstore and latest, I've given the command over here. So this is the copy. So let me pull that one also. Now, there you go. There you go. So I'm executing. Let it pull. It's going to take some time. So let's not waste time here. We'll come back and see this. Now let's come back to the images. All these things I'm using because I'm a little lazy. We have to do it with the commands, but as this is the first time we are getting into this, we'll use tools and then later we'll change it back. Now, as I was mentioning, if you come and see that, how many layers are there? It's clearly showing this. Okay, and it's showing this nginx, and it executing, it exposed port 80. So right now this is an image. That means the read-only layers. Now we need to start the instance of this one. So we can execute a command. Now see this, this one also, it pulled. That's cool. So now we need to execute this one. So I'm going here. It's already, we can view the details. And if you have something latest, we can use it Docker pull from here. So it will see that those layers exist and it shouldn't do anything. It says that nginx is latest. That's cool. Then let's come to the containers. And okay, so containers, and we don't have any nginx containers. No. Okay, that's pretty cool then. So one thing what we can do it here is Docker run nginx, Docker run, and name I give hello nginx, and we can do the port mapping. I just wanted to use those two, so let's use this help. One is the name and one is the port mapping. So publish all exposed ports to random ports. This is one, and this is name. We are not going to use anything else. One is hyphen name. It doesn't have the short syntax, and the port publishing is P. Okay, so lowercase. See that there is a uppercase P, there is a lowercase p. So we are publishing the specified post. Publish a container port to host port. Okay, so what does that mean is Docker ps hyphen a. You can see that the port mapping, it will be displayed here. But anyways, let's run that. Docker run hyphen name hello nginx. Okay, and port mapping, we are saying that 8001, map it to 80 nginx. So right now what is happening is it is being executed, and let's see. If I go to 8001, it is showing. But if I stop it, it's stuck. Actually, I should use the detached mode. Anyways, let's come back to this container. We can kill it from here. So I'm stopping it from here. So that will kill this. Taking little time. So this will kill it. Okay, it killed it. So now you can see this. You can run this from here also. You can stop it, or you can come in here and you can run it from here. You will have the same facilities, right? So if I come and see this, what can I do? You can do this Docker run, and that is exited. We should do it in a detached mode. That is one thing which I missed it. So if you see Docker ps hyphen hey, you can see that the nginx was started and it stopped. So we can again start as we have seen it here. So all we can do is click on this button, or we can do Docker start that container. Now, if I come back to this one and see this, I'm seeing you can get into this to verify the logs. I clear the log and I'll come and do one refresh. You see that from localhost we referred it. Okay, that is that easy. Now let's execute the other image, books image. That's my this thing. So let's copy this and let's do Docker run in detached mode, name books store, and the port mapping I would like to give 8002 to 80. So 80 port is inside the container, 8002 port is on the host versus container port. Okay, now I'll paste this image. We can do the image ID or the name of the image. So just to be in sync, I will go back and bring in the image name. Can copy it from here, isn't it? Because that recognizes. But equally, I can give the image ID also. Both are same. So this is the container ID. So now if I go and do that 31cdd, that's a container image. You can see that now it is up. So I can go ahead and use this port 8002. So that will bring in this. We can again come back to the Docker desktop to see that the bookstore, it's being executed. And right now we mapped only one port. And let me delete all. And if I come and click on books, so it spins and it shows that. Now you can see this logs. So what did we do since past 30 minutes? Let's quickly recap before we go further into the this AWS and ECS world. Okay, just want to see no queries. Okay, that's cool. So let's come back here. So first thing, we try to understand what is this Docker architecture. What is this Docker? And I'm not getting deep into that comparison between Docker and virtual machine. That itself is an entire ocean. So it's just enough Docker for us to get into the ECS world. So we saw that Docker architecture. We saw Docker server, Docker client, Docker daemon, what is Docker images, Docker containers, and registries. And we also saw that image is a layered thing. That too, read-only layers. And there will be a thin writable layer, and that will get destroyed as soon as we stop or delete delete this container. And another thing is we saw how to pull the images from some registry and how to execute it locally and access it. And similarly, we tried the reverse proxy nginx server and also a custom image, which I developed 1 year ago. We used it. So now we have enough fundamentals about these things like containers, how to run container applications locally. Okay. Now let's get into the world of ECS. That was just enough ECS. And again, we'll come back again and again. We are not going to leave it. We will, it's a series and it will take time, but we'll slowly learn piece by piece. Okay. So Amazon Elastic Container Service. So now you understood why did we learn just enough Docker in the container stuff so that we can use Amazon Elastic Container Service. So if I go to this here, so let's get some fundamentals here. So Amazon Elastic ECS, let me call this ECS is easy. ECS is highly scalable and fast container management service. Okay, you can use to run, stop, manage containers on a cluster, right? A cluster of virtual machines on which you can use this one. Okay, so your containers will be defined in a task definition to run individual task or task within a service. That means you will define that, hey, I want to run this nginx server inside a task definition. Or you can say that, hey, I want to run Vishipilo's bookstore in this task definition. You will define that. So after defining the task, you can execute the task independently, or you can execute it within the service. So the one difference is if you execute the task definition within the service, now it will be the responsibility of the service to ensure that if at all the task has been stopped or something happened to the task, it will ensure that, hey, I have to run these many tasks. So let's assume that bookstore, I want 10 instances of the bookstore. I'm expecting today is Sunday, a lot of people will buy books from my website. So I will bump it up to 10 instances. We call it as tasks. Execute this task definition, 10 tasks. That means 10 instances should be executed. Now service will take care of ensuring that it is there. Okay, we'll come back and touch upon that. And before that, we'll see that AWS FarGate. So actually, what is this FarGate? I mean, we are, as I was mentioning, this is just enough Docker and just enough ECS, so that we know what are we doing. And then we'll again come back. So rest of this year, we will be playing with microservices, Docker, ECR, container registry, container service, Kubernetes, and other services. But year 2023 is for Dockers and containers. Purely container applications will focus. And we'll use, like, we might come back and revisit how do you deploy a container a container application into ECS, a container application using Elastic Beam, and how do you containerize Lambda, and how do you execute the container using ECS or FarGate. And across the spectrum, you can come and learn that how much support it has got, and what is the differences, and what are all the nitty-gritties between these services. We'll learn a lot. So purely the microservices and the containers, year 2023 in the series. Okay. AWS FarGate is a technology, okay, that we can use with ECS to run the containers without having to manage the servers or clusters of Amazon EC2. So that means it's a serverless FarGate. So internally, it is managing the cluster. That means how many EC2 instances, what type of EC2 instance, everything it is going to take care. And we'll come back and dig deeper. But as of now, we'll ensure we have only this much of knowledge. Okay. The key components is cluster. Okay. A cluster is logical grouping of tasks or services. So underlying, you need to have the EC2, the instance where you have to deploy. But as of now, ECS cluster is logical grouping of tasks and services. Okay. And you can use cluster to isolate your application. Okay. When the tasks are run through FarGate, your cluster resources are also managed by the FarGate. We'll see both the versions, but at least for the next 2 episodes, we'll use FarGate. We'll not come into the managing the cluster using EC2, because that's a little bit more we have to do. But let's learn the easiest way and then we'll go. Okay, the task definition is a file. It will be in the JSON format where we will define that what is the image which you want to pull, what ports you want to expose, and you can specify the CPU and the limits what each container can have. All those things will be here. And task is an instance, like we saw the container, what we call container in the local, the same thing it's called as task in ECS. See, this task is an instantiation of the task definition within a cluster. Task definition itself is you're speaking about a container. In the task definition, you're saying that, hey, I want an nginx container and it has to expose this port, this much of CPU. And the same thing, you see that here, you see image. Image is what? Is a layered thing. So you're speaking about image in the task definition. The task definition is you're speaking about the image, what image we should take, how much memory it should allocate, if at all that container gets executed. And that is number of containers or number of containers. Technically, it's number of containers, purely as simple as that. That means number of task definition. After you create your application within ECS, you can specify the number of tasks to run on the cluster. That means number of instances. You want 2 instances or 10 instances. And service is used. So you can use AWS ECS service to run and maintain your desired number of tasks simultaneously. Okay, how it works? If any of your tasks fail or stop for any reason, Amazon ECS service scheduler launch another instance based on your task definition. That means if you dismantle that, it will come back again. That's one thing. And another important thing, I think we have learned just enough theory, but I want to touch on this piece also. So the launch type is something we will learn. You can specify an Amazon ECS launch type when you run a standalone task or create a service. Okay, so by doing so, what is that is determines the infrastructure. Okay, infrastructure. How do you manage the infrastructure? That's what. If you take the launch type as FarGate, so if you use the launch type of FarGate to run the containerized application without the need for provisioning and managing the underlying thing, that means you can see that all these instances is being taken care by the FarGate. Like you can see this Amazon ECS cluster. Okay, elastic network interfaces and provisioning. See this availability zone 1, availability zone 2, the provisioning of virtual private cloud, VPC, everything is being taken care. You have the task definition, and you can wrap this bunch of tasks here within the service. You can, as I was mentioning, you can individually execute the task definition. That means everything is your responsibility. Now you drop it into the service. Now service will take care. I forgot the term. The service will ensure that the desired number of tasks are being executed. Now, if here is this image type. Now, and you can see that whether it is coming from any container registry. So Amazon ECR or Docker Hub in this example. And this is the CloudFormation template. We'll see that in a minute. And EC2 launch type. So EC2 launch type is like you can get it from Amazon ECR, Docker Hub, or self-hosted registry. Again, now it will be our duty to create a VPC and availability zones, place the place this EC2s, all these things. So the external launch type we'll discuss a little later. I didn't go through that, but as of now, we'll see the FarGate and the EC2 launch type, those two things. So for the next couple of episodes, let's purely focus on the FarGate. So next, what did we do is 30,000 foot of what is ECS and Fargate. That means just enough ECS and Fargate. Now, we did two experiments. One experiment was how to deploy this nginx and access it. And similar thing is how to deploy the custom application, which I developed 1 year ago. We did that. So let's redo that in, oh, what? ECS. I'm sorry, it's not ECD. God. I'm sorry for my typo. ECS, right? So I think we have enough of theoretical knowledge. Anything which we missed now, we'll always come back and redo that. So the first experiment is, that's a good article. Where did I keep it? Ah. So let's go to this one. I think this is the right one. No. It's not this. It's another one. Is it the lab? I think it's in this lab. No, not this one. It will be part of that. So I'll tell you the crux. I just wanted to show you the documentation before we do that. So when I come in here to the cluster and click on this, it directly takes me to the cluster navigation. And here you can see this AWS FarGate. That's a serverless. We can define like what is this instance. Now we need to have a scaling group. We need to select what is the architecture and what is the size of this and minimum, maximum, and the keys and a lot of things we need to define. So thought that we'll start simple and then we'll go. So the namespace is this one. So you can see that namespace groups together Amazon ECS services to configure common connectivity. So grouping logical namespace. And you can see that the task definition. So inside this task definition, you will speak about what the task definitions are. So you can, as I was mentioning, you can tell that what is this nginx. The name is nginx, and it can take maximum of 256 CPU, and this one, and the port mapping, container mapping. Now you understand. In our case, if I go to do this, we had 8002 to 80. Now here we are mapping the container port is this one, 80, and the host port is 80, and here 8002.
Daddy,
yeah.
Mummy, chala predrastundi.
So it's my son, younger one. So container port and host port. So this is all we are speaking about an individual container, isn't it? Well, what the container should be, what should be the image name, the CPU memory limit, and the port mappings, and all the other things we'll speak about purely. So you can download this and we can reuse it. Okay. So capabilities, either the launch type, technically, either you can have the EC2 or FarGate, but we have selected to go ahead with the FarGate. Okay. I think that's enough knowledge for us to go and play around with this one. Now, how do we start? Do you want to go ahead and create and go through the painful process, or do something simple, learn, get our fundamentals stronger, and move forward? So I love to do a simplest baby steps. Take a baby steps and learn, move towards the toughest. The thing is that we are not seeing, nowhere we are seeing this getting started. So I was scratching my head. Hey, the documentation says that you can use the existing images, but where? That's, if at all, new ECS experience. We have to shut down that. Switch off. When you switch off this new ECS thing, then that's where it gives you the old UI, which gives you the getting started. So there you go. You can see that now the getting started. Now, if I switch back to the new ECS experience, maybe it might come in future. They might be working on it. I'm really not sure, but at least I couldn't find this. So the AWS documentation says that go switch it off. So we switched it off. Now you see this, it's entirely different. It says that clusters, you have task definition, account settings, and clusters on EKS, Kubernetes, and ECS. Just give me 5 minutes. Let's do that. So the documentation here. Now let's do getting started. Now you see this, all the things which we spoke previously in the diagram. At least 30,000 foot. I'm not telling that we did a deep dive on each of those things, but we at least touched upon, we know just enough things to play around. Now the container definition, I'm not writing a single thing. I can always come and do an edit here. I can call it as hello nginx, and that's an image. It is repository, and this is soft limit, and what is port mapping is 80. Okay, that's a container port, and you can get into the advanced container to create this, the health check on what endpoint we should do the health check and all those things. We are not getting deep into the weeds at this point of time. We might never, I don't know, but I'm telling you. So we called it as hello nginx instead of this is a sample application which comes. This is Tomcat, and this is custom image. We use this one also. At this point of time, we have taken that, and that itself is a task definition. It's a blueprint of our application. Is okay. So we have we have created the container and task. So you can see that the task definition means it is speaking about a container. That means we are saying that, hey, take this image, and this container should have 0.5 GB of RAM, so and so. These are the port mappings. Suppose if your application, there's a Node.js application, you're exposing 3000 as a port, then you should tell that here where we did the edit, we saw the port mappings. This is the container port here, 80, because nginx exposes 80. We have seen that. And suppose if you have written a Node.js and you're exposing it on port 3000, so that should be 3000. So those kind of configurations, all we are doing it here. So that's purely, you can see this, whatever we are doing at this point of time is a task definition. That is purely defining what containers should do and everything related to the container. Okay. And now here we are telling that task execution role. We'll come back to all these things, but at this point of time, let's go and play around with this. So if you see that the moment you did that, it says that, okay, to execute this image as a container, I need to do ABC, or it should have ABC. That's what we decided. Now we are defining a service. So the advantage of defining the service is it will ensure that the desired number of instances or the container, the desired number of containers will execute at any given point of time. For any reason, any of the container gets dismantled or failed or someone killed it wantedly, it will relaunch it. Okay, service allow you to run and maintain the specified number of the container. It's as simple as that. Okay, we are saying that desired number of tasks is 1, and the security group and the load balancer type is none. And here, what should be the cluster name? Without hello, we can't do. Hello nginx cluster. Okay, automatically it is taking care of VPC, the subnets, and all the things whatever is required. I was telling, isn't it? Uh, I've shown those launch types. Everything will be on our shoulders. So we have a task definition, we have a service, and we have a cluster where all these things will get launched. And I say create. Now, once I do create, so it is creating this one. So immediately we can switch back to the CloudFormation and see this. This cluster is being provisioned. You can see that events, it shows that what all the things. Okay, it is creating a VPC, and it is creating the internet gateway, and it is creating internet gateway, it is creating this uh, uh, VPC, and it is creating the service. So you can do refresh on this. So some of the things it has completed. Okay, like ECS security group and availability zone 2, availability zone 1, and a lot of other things. But we can stick here, we can see this, some of the things which has been completed, some of the things which is spinning. But behind the scenes, you can do a cloud watch, and the guy who's doing all these things is this CloudFormation. Always we can go back to the cloud watch here, and here you can see that this process it's being created. Oh, I think it's completed, but let's see that what is that we'll be able to get it out of this. Okay, so see this, all these things has been completed, and I can check the logs. Might take 1 or 2 minutes, but the next one, whatever we are doing, the custom image, we might go little. We should do. It might take some time. We'll come back and revisit. But at this point of time, we understand that once you create a cluster in the service, like ECS using FarGate, so behind the scene there is one CloudFormation template which is creating it, and you can track back its logs. I think this is yesterday's, if I'm not wrong. Yeah, 13 hours ago. Midnight I was doing these experiments. Okay, so let's wait. Let's give it 10-15 minutes time. Anyways, we will be here for 10-15 minutes at least. And now let's come back to the service. View the service. Now you can come back to the task definition. See, this is the one. So here, hello nginx cluster. So we have one service, and number of running tasks is 1. This was the previous one, yesterday's one. Okay, so I'll leave it as it is. Let's get into this cluster. Once you get into this cluster, here you are seeing that the tasks which you have defined, okay, and the service and ECS instances. And you can see that the running tasks is 1 and active service count is 1. So this is the tasks, means a container. This is the service. You're selling that the desired tasks and the running tasks. So if I say desired is 10, running is 1, means it is spinning something else. So what we will do is we'll go to this tasks. It is running. So if I come in to this task, and here is this container. Let's get into the details. We'll see this network, and this is the container definition, which is running, and it has got the public IP. So I can take this public IP. I will go here and paste it. So now it is showing the nginx, the same experiment which we did it with the Docker. So again, let's come back to this one. You can find this task definition over here, or let's come to the cluster. Let's not go here and there. Let's come to this nginx cluster. We had a service, and in the service, you click on the service, and the details is that we don't have the load balancer. We didn't enable that. We will enable to the custom application which we are doing in next 4 minutes. So you will have this one. Auto assign public IP was enabled. That's the reason it enabled the public IP for that. And if you come and see, the tasks are running, and you can look into the events, what kind of events happen here. And auto scaling we didn't do, and the deployment you can check that. Desired count, if the desired count is 3 and running is 1, that means 2 pending. And metrics, all the CPU utilization and these kind of things. We'll do a deep dive little later in 1 or 2 episodes from now. But at this point of time, let's stick to the game plan. I will close this and also close this. Okay. Now let's come and redo another cluster, another getting started. And here, this time I will come in here and I will call it as Swami's bookstore. Okay. Now we need to have the image repo. That's my repository, and the image name and latest. And I'm leaving all. Now the container port is 80 because that's what we tested in the local. Now here, that's a bookstore. 8002 to 80. So the container port is 80. So we are mentioning the container port. Now you guys should understand, why did we start with Docker? And now why are we coming here? So now you know that what is that port mapping means, the host port versus the container port, and what is image, what is software bills of material. Now you can correlate what are we doing. So that's the reason I thought that that foundation will definitely help us to understand the ECS and Fargate. So we have created the definition name. Instead of calling it as that, I'm calling it as books store. Okay. And I'm keeping rest of the things and saving it. Now this we can differentiate, because at the time when we went, everything was like run task or the same name it was. Okay. Now it clearly differentiates. Now we are leaving all the defaults. Now we have the task definition. I'm executing my task, and the service name is Swami's bookstore service, and the number of desired tasks. we will say that I want 3 instances of this. Okay, so you're paying more, guys, please understand. Now previously each task will have each container or each task, let's stick to the terminology, each task will have a public IP, we can reach that way. But when we have having multiple tasks, it makes sense to use the load balancer. So load balancer listens in 80 now, and this is the Swami's books store cluster. Click on next, and here we have everything. So task definition, that means we are speaking about a container. Service means we are saying how many desired number of tasks should run, and this everything will run in a clustered logical grouping where everything gets executed. Now cross the fingers, it's creating. Now let's come back to the CloudWatch. I think we got actually I got confused because the name was I didn't change it. It was my mistake. If not, we would have seen that. This was very good thing. Like, I first run tasks, something like that. I didn't change it. That was the reason we went into the confusion. At least I went into the confusion, but I want to pull you guys also into the confusion. So no, it's like together we are confused. Now let's see this again. It's provisioning that. And you can see the resources, what resources it is provisioning. So security group and gateway and target group, load balancer, internet gateway, subnets, route table, and the virtual private cloud. So now let's spend a couple of sessions to learn and fix our fundamentals on this one before we go ahead and create all these things, right? So it makes sense to do that. Again, let me come back over here. So 1, 2, 3, 4, 5. So 50% of the world piece we do have. And let's come back to see the stack info. And let's do a refresh, and you can see the logs over here, the log stream. So you can see that the logs are existing. And let's go back to the another one, the latest. I think it will definitely take time, isn't it? It has to go to the centralized store, and from there, they might split and drop it, or they might flush it directly as a live streaming. I don't know. So I'm just telling that we need to wait for some more time. And it is still in the progress. You can see that other clusters are create complete. So wait. Three stacks. Oh, I wanted to show you one more important thing in this. Let's see in this one. I wanted to show you one important thing in this one. This one. Yeah, I wanted to show you this one while it's cooking up. See this. To create this, what all the things it needs. So you can see that ECS AMI ID and the instant type and the ECS cluster and the port. You can see that the health check target, VPC, and all the resources. See availability zone and availability zone 1, availability zone 2, internet gateway. That template we can get it from here. I mean, once you do it manually and you got the view in the design, you got this CloudFormation template, then it'll be easy for you to reuse it in multiple places, isn't it? So you can come and see the diagram over here. See that? I will make this a little bit bigger. Now, behind the scenes, what is happening? You will see that. So see this public subnet, and there's another public subnet. This is the security group. This is application load balancer security group. You have the route table. All these things are coming in here. So that was an extra tip which we have gained today. So that's the CloudFormation. So we saw that the CloudFormation, which shows that you can track the events, you can track the resources which are getting created, and you can get the template and you can view it in the designer. And similarly, you can see the CloudWatch. See that it's flashing out. It definitely takes time, isn't it? It goes to a centralized location or somewhere, and then it has to stream it asynchronously. And I think it's done here. Let's go and see. Oh, that's one important. Ah, God, I deleted that. Apologies, guys. Actually, I should have shown you that. Let's do that. Let's say update. Okay, the number of tasks, I'm saying 5. Skip to review and update the service, because as we spoke, the service is a 1 which will ensure that. See this, the desired count is 5, the running count is 3. That means 2 more items or the 2 more tasks are the containers. Okay, I'm getting mixed up the terminology. So that means technically it's a container. It's nothing more than that. So you can see that. So provisioning. So there should be 5. So 3 are running and 2 are getting provision. That's cool. So let's go to this details. And we have the target group and we have the load balancing also. Okay. I will come in here. I can check this auto scaling. This is the target group. And now, where is that? This is the target group, and target is 5. So 3 are healthy, 2 is initializing. Let's go to the load balancer. And here we'll get the load balancer. The DNS is this. I copied the DNS and I'll paste it here. It still shows me this because we have a load balancer in front of these instances. So we can see that pending count is 2. Still, we are getting this application. I can go and click on books. It does retrieve it from the in memory, and I'm able to do. So every time I hit this from different places, it might go to different instances. You can see this. Some of the instances are still being provisioned, or now it is all is running. But still, now this load is being distributed between all these things. Okay. So that's it for this month's session. Hope you guys have learned something new. Let's do a quick recap. First, we started discussing on Docker, just enough Docker. We understood about the architecture, server, client, image, container, and registries. And then we did the hands-on. And then when we came and spoke about the ECS and Fargate, just enough to get the terminology, like what is the cluster, what is task definition, service, task, and cluster. And the launch type FarGate is a serverless, and EC2 we have to provision the VPCs and all subnets. It's on our shoulders, but here this guy is taking care of the FarGate. And then we redid the same experiments about the nginx server as well as the custom application. And cool, I see no queries, so I think all is well. So in the next session, we will do the similar application. We'll do two things. We will do one static and one ASP.NET, maybe Web API or Minimal API or Razor Pages or Laser WASM. I don't know what it is, but we will definitely do create a brand new fresh application. We will containerize, execute it locally, push it to the Docker Hub, and again do the same thing, host it in the ECS FarGate. Okay, and please keep a watch on the meetup, and see you in the next month episode. Bye.